Hello. From lesson 1, we have been learning how to solve simultaneous equations using different methods like elimination, substitution, comparison, and even graphical methods. We have also learned how to solve simultaneous equations where one is linear and the other one is quadratic. Now, in this new lesson, I want us to learn how to solve simultaneous equations relating to speed, distance, and time. But before we start solving the problems, can we first understand the logic of this formula? So, when I say distance is equals to speed multiplied by time, I mean if I have two moving objects, or if I have a moving object, then distance covered by that object is given by the speed of that object multiplied by time. That object can be a car, can be a bicycle, can be a plane, or another moving object. Then, since I know distance is given by speed multiplied by time, then let's say distance is given by d is equals to s multiplied by t, each to represent either distance, speed, or time. So if I know distance is given by speed multiplied by time, then I can also know what is speed from this one, because I only need to divide m by t, and then to get the formula for speed, and then also divide m by t. So now I'd say distance over time is equals to, I cancel this t with this, then I say s. So speed is given by this d over t, which is distance over time. How about the time itself? The original formula is distance is equals to speed multiplied by time. So time then will be given by, I divide m by s, so m by s, so it will be distance over speed, like that. So with this logic, we can use this formula to solve questions relating to distance, time, and speed. Can we try an example? Here you are told a car travels 90 kilometers at a speed of x kilometers per hour, and then a bus travels the same 90 kilometers at a speed of y kilometers per hour, and then the bus takes 3 hours longer than the car. The car travels 15 kilometers per hour faster than the bus. Then you are told to find the speed of each vehicle. Then from this, first of all, I know I have two vehicles, which is a car and a bus. So I can just say I have a car and a bus. But you see, in each of them, I want to know the distance, the time, and the speed of each of them. Then distance, time, and speed. So that we can use all that to apply in this, our formula where we have distance is equals to speed multiplied by time. So I need to have distance, speed, and time. So I'm going back to the question. You can see a car travels 90 kilometers, and then also a bus travels the same 90 kilometers. So both vehicles travel the same distance, which is 90 kilometers, like this. Then you are told the speed of the car is x kilometers per hour, and then the speed of the bus is y kilometers per hour. So I already know the speed of each of them. This one is x kilometers per hour, and this one is y kilometers per hour, like that. And then you're also told we don't know the time of any of them because we are not given the time here, the exact time. But then since I have the distance and the speed, and I have this formula where I say distance is equals to speed multiplied by time, then I can say time is given by distance over speed. And I already have the distance, I already have the speed. Yeah. So d, which is 90 over and speed, which is x, that now remains the time for car, and then the time for bus will be 90 over y, because y is the speed. So I already have the distance, time, and speed for each of the vehicles. But look, you are told the bus takes 3 hours longer than the car, meaning if For example, let's say if the car arrived or rather covered those 90 kilometers by 11 a.m., for example, the bus would cover them from 11 a.m. There would be extra 3 hours so that the bus can cover the same 90 kilometers. So let's say if the car arrived at the destination at 11 a.m., the bus would arrive at 11 a.m. for plus 3 hours, which is 2 p.m. like that. So since we don't have exact values for this time here, then it means, you see here, I added the time the car arrived, I added 3 hours. So can I do the same here now? Meaning, if I add 3 hours here, then this time will be equal to this time, because this is the time the car took to arrive at the destination was 9/x, but then when I add 3 hours, it's kind of like I say if the car arrived at 11 a.m., then I add 3 hours, I'll get the time the bus will arrive, which is 2 p.m. So in this case, then it means if I take 9/x plus 3 hours, I'll get this time for the bus. Then it means both will be equal. So 90/x plus 3 will now be equal to 90/y, like that. And that becomes our first equation. But then, if we go back to the question again, you are told the car travels 15 kilometers faster than the bus. So logically, this is what it means. Let's say, for example, if the real speed of this bus was 60 kilometers per hour, like this, to get the real speed of the car, you would add 15 kilometers per hour. So the car would be traveling at 75 kilometers per hour. But you see, we don't have the exact values for speed. We have the unknowns x and y. So what then that means is this x, for example, let's say this y is now the 60, but we want to get the speed of this one because the car travels 15 kilometers faster than the bus. So if I add 15 here, then the speed of both vehicles will be the same. So then I would say x is the same as y plus 15. And this becomes our second equation here. X is equals to y plus 15, like this. I can call that the second equation. So now you see we have the two simultaneous equations already. Now that we have the two equations and we learned the substitution method, can we use it to solve these two simultaneous equations? I can say in equation 1, in any place we have x, I'll substitute it with this y plus 15. So if I do that, then it will be 90 over, I already have x here, so it will be y plus 15, now plus 3, this one is equals to 90 divided by y, like that. But you see, I can put this one over 1 like this. But you see now we have a question here which we need to find the LCM. But I want to show you a simple way. Instead of finding the LCM and putting all that division, you can do this. Take all the values here and multiply them. So 1, if you multiply by y, it will remain to be y. But also if you multiply by y plus 15, it will still remain to be y plus 15. So what I can do is, I can take this y, then multiply it by y plus 15, this one. But I will not open the brackets. I just leave it like that. So now I come here and say 90 all over y plus 15. But you see, I want to remove these values here. So what I can do is, let me multiply the whole of this with this y into y plus 15. Then again, I add 3, my 3, this one. Then I multiply again by this y into y plus 15 like this. And then is equals to 9 over y. But then also multiply by this y into y plus 15 like this. So here, this y plus 15 goes with this one, and I remain with 9y plus this one here, because there is nothing over, it was over 1, so 1 divided by this one, it remain to be 1. So I multiply this one, y by y squared by y to be y squared. Then again, y multiplied by 15, it will be 15y plus 15y. But you see, we also have a 3 here, so 15y multiplied by 3, it will be 45y. Then here I forgot to multiply by 3, so it will be 3y squared. Then is equals to this y goes with this one, and I remain with 90 here. So 90 multiplied by y, it will be 90y, then plus 90 multiplied by 50, which is 1350. And there we have our substituted equation. Can we now try to solve with first is to collect like terms together, and in this case it will be 90y plus 45y plus 3y squared. I think this side is okay, and then I can also take this 90y on the other side, which now will become minus 90y is equals to 1350 like that. So this 90y minus this 90y, they cancel. So I remain with the 3y squared plus this 45y, but is equals to 1350 like that. And then I can also say 3y squared plus 45y. Then I take this one on the other side, which is minus 1350 is equals to 0. And now it becomes a quadratic equation, which we can use factorization to solve it. Before we even do factorization, can we just divide all these values by 3, because they are divisible by 3. So if I do by 3 here, by 3 here, and by 3 here, it will be y squared plus 15y minus, I can use a calculator here, I say 15 divided by 3, which is 450. So minus 450 is equals to 0, like that. So to do factorization, I need two numbers, which when I add them, then give me 15, and when I multiply them, then give me negative, let's say multiply, then give me negative 450, like this. Those two numbers will be 30 and negative 15, because if I add 30 and negative 15, it will be 30 minus 15, which is 15. And then if I multiply that by 15, negative 15, it will give me negative 450. So now I factorize those values here, which now becomes y squared plus that y minus 15y minus 450 to be equal to 0, like that. So I can group them like this. And then I get here, I have y, which is commonly, so it will be y into y minus 30, which is y multiplied by that, it will be 31. This is plus, not minus. Then minus 15 here into y. This one, because y multiplied by 15, now it will be negative 15y, plus then negative 15 multiplied by this, I think it will be that again, because negative 15 multiplied by that, it will be negative 415 is equals to 0. So I have y minus 15 and then y plus 30. Either of them should total to 0. So if I open the brackets, let me open them here, then I'll say y minus 15 is equals to 0, which means then y is equals to 15, and also y plus 30 is equals to 0, which means y is equals to negative 30. Then in this case, we don't have a negative speed, so we cancel this one and remain with this speed, which is positive. Y is equals to 15 kilometers per hour. But you see, y was the speed of the bus. Let me show you. So if the speed of the bus was y, and we have already got y is 15, then that means it's the speed of the bus, 15 kilometers per hour. But then the question, I already know the speed of the bus was 15 kilometers per hour. So the speed of this car would be then 15, which is for the bus, plus another 15, because you are told the car travels 15 kilometers faster than the bus. So the speed of the car will be 30 kilometers per hour, like that. Now, following this logic, can you try to solve these questions? And if there is any of them which has issues or problems, you can leave a comment or ask me any of them. I'll try to answer, and I'll also solve any question you give me. And bye for now. Let us meet in the next lesson. Let me move upwards so that you can see all the questions before I leave.